To build a high-contrast dessert, you don't always need an oven. You just need to know how to stack specific textures, like this dense, dark cookie foundation beneath a layer of velvety cream. Constructing these layers relies on controlling temperature and managing the physical states of your ingredients. This exploded view diagram shows the complete material list. We need a cookie matrix, one standard package of chocolate sandwich cookies alongside a 1/4 cup of butter. Then our dairy fats, 8 ounces of cream cheese and 1½ cups of heavy cream. Finally, 1 cup of powdered sugar to act as our stabilizer. By combining these specific ratios with the right thermal conditions, you can assemble the components in 15 minutes before allowing the refrigerator to set the structure. Step 1 is processing the raw materials for our base. Take the whole cookies, creamy filling included, and crush them down into a coarse aggregate. Next, introduce warm liquid butter. Watch how the melted fat coats the dark crumbs, binding them into a cohesive material that resembles wet sand. Portion about a tablespoon of this butter bond aggregate into the bottom of individual glass cups. This pressure map visualization demonstrates a failure point in the build. If you tamp the crumbs down too hard, you compress out all the air gaps, turning the base into a solid brick. Instead, a light tap is all you need. Leaving that base loosely packed maintains enough structural integrity to hold the cream layer above, while ensuring it yields easily to a spoon later on. For the filling layer, start with the cream cheese. It is a requirement that this dairy fat sits out until it reaches room temperature. If you try to mix cold cream cheese, the fat structures remain rigid. You will end up with uncorrectable, dense lumps dispersed throughout your filling. Once the cream cheese is soft, gradually mix in the powdered sugar. The fine sugar crystals dissolve rapidly, stabilizing the soft fat structure of the cheese. Now we introduce the vanilla extract and the heavy cream. Unlike the cheese, this heavy cream must be ice cold. Low temperatures are required for the cream's fat globules to effectively capture and hold air. Aerate the mixture at high speed. Notice in this macro shot how the liquid thickens and gains volume. The beaters lift away to reveal a stiff peak that stays in place even when turned upside down. To finish the filling, take a handful of roughly crushed cookie pieces and gently fold them in. The goal is to distribute the texture evenly without deflating the air pockets we just built. By managing these temperature differentials, warm cream cheese and ice-cold heavy cream, we turned dense dairy fats into a light, suspended emulsion. Load the aerated filling into a piping bag with the corner snipped off. This gives you control during assembly. Guide the piping bag into each glass and squeeze, layering the white filling directly over the dark base until the cup is 3/4 full. Using transparent cups highlights the clean lines between the dark aggregate and the white cream. Now comes the final requirement, thermal stabilization. The cups must go into the refrigerator so the dairy fats can physically lock into place. This timeline illustrates the chilling process. As temperature drops, fats solidify, securing air bubbles over a mandatory 3-hour window. If interrupted early, the internal fat structure fails. The emulsion collapses, reverting the dessert to a runny liquid. Allowing the proper time for thermal stabilization ensures the layers stay distinct and the cream remains set. After 3 hours, the cups emerge set and stable. The frosty condensation on the glass proves the thermal process is complete. Apply a final dusting of cookie crumbs, or a single mini cookie directly on top to signal the flavor profile. The test is the first bite. The spoon glides through the firm cream and yields through the loosely packed cookie base without resistance. By managing physical states, the crunch of an aggregate and the temperature of dairy fats, you can engineer a sturdy dessert from scratch.